Hey everyone, hopefully you're having a better night than I am. But as promised, I am here. Although I have 60 million two things, but I'm here to help, to educate, to push as best as I can. So, let's get paper out. Let's get pencils out. Let's get everything out. Because today we're going to work a little bit on a geometric concept, which sometimes a lot of people tend to get mixed up. So again, thank you so much for coming in. Soda Pop Curtis. Man, I haven't seen that name in a minute. How are you? So as promised, we are going to go through arc measures, arc lengths, as well as area of a sector. So, Deja, how are you? So, we are actually looking at arc measures and arc lengths and also the areas of those sectors. So, when we're looking at this, and I kind of mentioned it during my event for Pi Day. So, there's different things that when you're dealing, especially with circles, that we have to kind of keep in our brains. So one of them is the formula for the circumference. So the circumference is what goes around the circle. So you can see the circumference in one of two ways. It's either your pi times the diameter, or it's 2 pi r. So if they give you the radius and they say we want you to find the circumference, use 2 pi r. If they give you the whole diameter, you could divide the diameter by 2 and then all of a sudden you're going to end up multiplying it again. So what's the point? So you can actually just leave it as a diameter and multiply it by your pi. Now, with the circumference, you also have the area. So area just has one formula. So it's your pi r squared. Okay? So pi r squared, that is going to be your area of the circle. So what happens inside of the circle. Now, the different things that we're going to see here is versus arc length versus the sector. Now, arc length, you're taking part of the whole circle. So the whole circle is 360. But arc length only deals with the outside, so the circumference. So a lot of people know it as 2 pi r. And some people actually reduce this a little bit further. But a lot of people generally know it's your theta meaning the measure of the angle, over 360, because that's how much an entire circle is. And you're going to multiply it by 2 pi r, which looks familiar, which is your circumference. Now the sector is just like when you're trying to find how much space one slice of pizza takes from a whole pie. So if I'm looking at the area, again, I'm taking the measure of that angle out of 360. But this time I'm going to multiply it by the area of the circle, which is your pi r squared. Okay, so these formulas are kind of, hey Marilyn, you missed the beginning? Not too much. I'm actually just getting started. All I did was announce that I'm going to be looking at arc measure versus arc length and look at the area of sector. So not too much missed. Okay. So if anything, we have our circumference, We have our arc length, which I'm going to talk about a little bit more. We have the area of the circle, and then we have our sector. So the area of the sector. So taking a further look, we're really looking at circles. Okay, some people are starting to get into circles from here on in. Some people are just kind of getting into some of the areas. But one of the things I really want to also, in order for you to get, especially arc length and sector area, we need to know the difference between the arcs. So we're not looking at a whole entire circle. We're just looking at parts of it. So we have something called major arc, minor arc, semicircles. So I'm going to actually try to break a lot of this stuff down to you for now. So when we're looking at a circle, so I want to do what's called a minor arc. A minor arc is the angle, the measure of the arc. The arc is this outside, okay? So the measure of that, that's less than 180. So an example of a minor arc would be this arc BC. Now, most of the time, arcs are being pronounced by just 2 letters. So the way that I write this minor arc, BC, and the reason why I say BC, or I could say BA or AB, is I'm telling you where I'm going to start and where I'm going to end. So if I said minor arc AB, that means I'm starting at A and I'm following up to B. If I want to say minor arc BC, that means I'm starting at B and I'm going to C. And if I wanted to say the other way around, if I wanted to say DC, that means I'm starting here at D and I'm going here to C. So any of the arc measures that's less than 180 degrees, that's less than half the circle, is a minor arc. So the way that you write it, and I'm going to say arc AB, is I write an A, a capital B, with an arc over top. Now, some places, especially on some assessments, you won't be able to get an arc. Sometimes they will write it like this, AB, and it looks like a little hat. Okay, so I've seen the little hats being shown to represent arcs, and I've actually seen the actual arc. So just to familiarize yourself when these things come up. Okay, well, hello. Can I explain tangents? Not tonight. Not tonight. I'm just hitting on what I need to hit on, and I am going to bed because I've been, really stressful day. So I'm trying to be as positive as I can because I'm ready to lose my mind. Okay, I just want to cry in a corner some days, and today is one of those days. But anyway, so the major arc, okay, so minor arcs are usually represented by two letters. But a major arc is usually represented by 3 letters, okay? So a major arc is going to be more than 180. So if I wanted to call a major arc, I could say arc ABD, okay? Notice I went through. Or I can name this ACD. Either way, I'm telling you where I'm going to start and where I'm going to end, and it has to go more than 180 degrees. So if I wanted to take it another way, I could say CBA. So that means I'm telling you where I'm starting at D, I'm going all the way to B to A. Okay? I can even say ACE. That's a major arc. So anything that's more than 180, but not quite 360, okay? So for us to name a major arc, let's say ACE, I'm writing out all 3 letters. I'm writing out ACE, and this is the arc. Okay. All right. So arc ACE is written out with 3 letters. This is where you start and this is where you end. Okay. And you just figure out one point that's along the way. All right. So semicircle. Semicircle, semi meaning half. So the semicircle, I can go from A to C, or I can go from C to A. Another one, I can go from B to E, or I can go from E to B. Okay, semicircles again, that's similar when you're trying to name it like a minor arc, but the only difference is I'm going from one point to the other point. It's usually going to represent your diameter. Okay, your diameter usually goes right through the center of your circle and it cuts your circle into 2 parts. So the way I represent my semicircle is very similar. So I'm going to say BE. So here's my B. Here's my E. And then I have my arc. So I got my arc BE. All right. I'm not taking any math courses at all, but I want to relearn this. It seems fun. All right, well, welcome in. Can you do a lesson for probability? You have a test soon? I will see what I can do. What subject is this? This is math. Just basically looking at a lot of the geometry. So, yeah, that's what it is. So now the next one is radius. Now, radius is from a point that's in the center of the circle to a point that's on the circle. So a lot of people, the length of this radius, which goes from point Q to C, Q to B, Q to A, Q to E, Q to D, they're all the same lengths. So from Q to C, that's a radius. Q to C, Q to B, Q to A, Q to E, Q to D, they're called radiids, plural. Okay, so I'll even spell it for you. Radiids. Double eyes. Okay, so as long as you have one point that's the center of the circle and the other point that is on the circle, that is called your radius. So I can go QC, and that is still a segment because I have 2 endpoints. Okay, so it's still going to be called a segment. Now, diameter, as I mentioned before, it's a chord that goes directly across the center of your circle. It goes through the center of your circle from 2 endpoints. So I can say AC, that's a diameter. I can also say BE, that's a diameter. Okay. How you call this? Try this again. How you call this kind of problems? What do you mean? Eli, what do you mean? I haven't seen you for a minute, so how are you? Let's back up. Okay. How do you know what I'm kind of learning right now? Oh, geometry. Yes, this is called geometry. I don't know. It just seems like it's a thing that a lot of my students are starting to pick up and they're starting to ask me on. So I usually just bring them to you guys because I figured, hey, someone's learning it. So might as well just put it on out there. Now, so that's basically how you name them. So a minor arc, you're naming it with 2 points. Major arc, you're naming it with 3. Semicircle, you're naming it with 2. It's basically taking over your diameter. All right, a radius goes from the center of the circle to a point on the circle. Okay, and the diameter, as I said before, is a chord that goes from one side to the other, and it has to go through the center of your circle. So now, This is the next part that I really wanted to emphasize. So let me zoom like a mother. Here we go. All right. I really want to emphasize what's called arc measure. A lot of people get arc measure and arc length confused. That's the main reason why I'm here. Okay? So when we're looking at arc measure, we are looking at the central angle. When I mean by central angle, I'm talking about your vertex, which is your turning point, is the center of your circle. And then the measure of this angle that it makes with your two radii, okay? The measure of this angle with the central angle is the same measure of its arc. Okay, so let me say that again. The central angle that includes, or the vertex is the center of the circle, the measure of this angle is the same measure for its arc. Okay, the arc is the side, the piece of the circle. All right. Okay. Oh no. What's wrong? Oh no, what? Should I not be here? I'm like starting to feel a little type of way. But now that we're looking at arc measure, all right, so we have KZ. So we're looking at the arc KZ. So if I look here, they're giving me a little bit of information. They're telling me that from Z to Y, that's 40 degrees. So that means the central angle right here is also 40 degrees. They're telling me that KS, the arc measure, is 20 degrees. So that means right inside here, I'm going to try to write it as small as I can. That is 20 degrees. Okay? Now, this is when it gets a little fun. Yes, when you do add those two up, it does give you 60. But we have a semicircle right here. And semicircles is half of a circle. And half of a circle is 180 degrees. Okay, just like the equation of a line. The measure of a line is 180 degrees. Supplementary angles is 180 degrees. Half of a circle is 180 degrees. So if I know that this angle is 20 and this angle is 40, what's the measure of this angle? Oh, so Audrey wants participation. Yes, she does. All right. If this whole or this semicircle, okay, is supposed to equal 180 degrees, this side's 20, this side's 40. What's the measure of this side? And you don't have to kill yourself with mental math. You know, just think about it. Okay, got a couple people. Yes. Okay. All right. Yes. So we got 120, 120, 120, 180 minus 60. Erase the question mark and go ahead and do it. What's 180 minus 60? Nampu got 120. Sister Vibes 120. Okay, that's 120. Awesome. Okay, so 20 plus 40 gives me 60. Okay, we got 180 minus 60 will give me 120 degrees. So if this central angle equals 120 degrees, that means this arc from K to Z is also measuring 120 degrees. Okay. She's like, math teacher. I was like, hey. But doesn't it feel good to like go through math when you don't have to be the teacher? Like you could just do it. Doesn't that feel good? It's just like, whoo, yes, I could just do math. Without people asking you 60 million two questions. All right, how do you know whether to multiply the central angle by 2 or keep it the same? Whether to multiply the central angle by 2? Why would I multiply the central angle by 2? Are you talking about inscribed angles? Are you talking about inscribed angles? When the angle is, I'll put it on my little piece of paper. This is a terrible circle, but here we are. So like if you have an angle that looks like this. Yes, yes. Okay. So this is when you have your angle, if your angle right here is 30, you would divide, because obviously it's turned into a smaller angle right here, right? So only when you have your vertex is on the circle, not in the central angle. Does that make sense? So if the vertex, let me see if I can do a side by side. Freehand circles, that's always funny. All right, so let's say that this is, we'll keep it with the 30-degree thing. So here, this will be 30 degrees as well. Okay, let me unzoom so you can see. All right, so kind of see the difference. The vertex is at the center of the circle. That's 30 degrees. When the vertex is on the back end of the circle, that's when you're going to take half and double. Make sense? Dot is on the circle, you would divide or multiply. Yes. Yes. Okay, makes sense? All right. You're cheating? Oh, you're welcome. All right. So we want to know what the measure of KZ is, and we just found it. It was going to be 120 degrees. So we could figure out the other side. Okay, we saw one side. Now we need to figure out the other side. Now, this is when it goes a little bit further into geometry, because we have almost what's called a pairing. There are some things that's called, and I'm going to see if I can put it, right here. So glad. Okay. So we have something called vertical angles. Now, with vertical angles, they basically create a V shape. Vertical begins with a V, and they create a V. So this is 120, and we found that. The angle directly across from it, and if I notice, if I had like some patty paper, or if I had some tracing paper, and if I trace this and I put a pin right here in the dead center and I kind of swung it around, it will match this side exactly. Okay? With vertical angles, they are congruent. Congruent, meaning the same. Okay? The same measurement. So if that's 120 degrees, that means this is also 120 degrees. So if this is 120 degrees, using the information over here, which angle Would it be Y, is that YOW? Or would it be SOV that equals 20 degrees? Would it be this angle 1 right here? Or would it be this angle 2 right here? Which one do you think? Based on what I just did with the 120. If you could take a guess, it's perfectly fine. You can take a guess. This is not Squid Games. You're not going to die. All right? So would it be angle SOV or angle YOW? Which one will measure 20 degrees? I have bra, okay? I have SONs, I have YOWs, I have SOVs, YOWs, Y and W. Okay. YOW because it's the vertical angle. Okay. All right. So remember, the 120 was directly across from the 120. If I have the 20 over here, it's not going to be the one next to it. It's going to be the one directly across from it. So YOW is actually going to also be 20 degrees. Okay. So YOW will also be 20 because SOV is also 20. No, SOV is not 20. SOV is not 20. Let's take a look at it again. Okay. You can move it over some. Okay. So Ava is saying SOV is 40. Do we agree with Ava? Okay, so we got semicircle equals 180 and the additional 20 wouldn't equal 180. Okay. Maybe use tick marks. We could use tick marks. But here's my thing. When you see the assessment, they don't use tick marks. So you're just going to have to learn. You're just going to have to learn. But I get it. But if you do it, you can use tick marks for your thing. That's perfectly fine. All right. So what's left over here, if this is 40 degrees, this also has to be 40 degrees. And if you add all those measurements up, if you add all those degrees up, what's the total? Okay, good. Yep, so we got some 360, 360, 360. Yes. So the total number. I love it when people say, man, that person really did a 360. You're like, no, they did a 180. If they're trying to change their lives, you don't want to do a 360. That takes you right back to the beginning. So if you really want to change your life, you're doing a 180. Okay, that means 1 minute you were going one way in the path, and next thing you know, you made a transformation. You made a change. Okay, you're not going back to right where you came from. All right. So when it comes to a circle, the entire degrees of a circle is 360. Half, if you divide 360 divided by 2, will give you 180. So if this side is going to equal 180, that means this side has to equal 180 so we can get our full 360. So now, with all this information, we want to know what K, the measurement from K to Y. What is the measurement from K, Y? What's the arc measure from K, Y? Go ahead, put it in the chat. What is the arc measure of K, starting at K and going to Y? How would I find that? Okay, so from K to Y, from K to Y, what is my measurement? What is my arc measurement? Okay, hey Cece. Hello, Hunter. We got like 160, 160. Yeah, like, oh, how are you? Good. WTV, drop the question mark. Good job. Good job. Confidence, people. Confidence. We got this. All right. So it's from K to Z is 120. From Z to Y is 40. So if I want to go from K to Y, that's going to be 160 degrees. Good. Oh, you're supposed to be on spring break? Yes, we'll be on spring break. Relax, because trust me, before you know it, it's time to get right back. You know these are not even a spring break. It's a spring moment, Cece. It's a moment. All right? So from K to Y, I'm going to put my 160 degrees. I know you can't see it, but I'm going to put it down. Now, if I want to know from Z, so the measure of arc, ZWS. Okay, here's it is. I'm starting here at Z. The arc measure is ZWS. Am I going to the left or am I going to the right when I'm trying to get to ZWS? Or let me put it this way. Is it a major arc or is it a minor arc? I'm telling you ZWS. So the ZWS. Is it a major arc or a minor arc? I got a person saying to the left. Okay, WTV saying it's a major arc. Your junior captain saying it's a major arc. Good. Hi, Heidi. Okay, hi, Abel's here. Major. Everyone's slowly coming back. I know. It's hard to like understand it, and like I had a whole calendar ready to when I was going to go live, and then of course I got more students this weekend, so yeah, gotta make these changes. What type of math is this? Right now it's a little bit of geometry. I don't know. Okay. Anytime they name 3 letters, okay? Ooh, sorry, my fingers were huge that day. Every time they name 3 letters, it's a major arc. Minor arcs, they only use 2 letters. So like from K to Z, that's a minor arc because it's less than 180 degrees. From K to Y, that's a minor arc because it's less than 180 degrees. But if I'm saying from ZWS, okay, we're not going to the left because if I go from Z, I'm going to get to S before I get to W. That's the wrong way. So Z, sometimes that middle letter tells you, all right, you're going in the right direction. So ZWS. So we're starting here at Z. I use another pencil. And I'm ending here at S. And I'm looking at this arc right here. Okay? So what's the measure from ZWS? What is that measure? Oh, good, Hunter. Nice. Oh, perfect. Can it be a major arc if it's 3 letters, but they don't add up to be 180? Yeah, major arcs is going to be more than 180. So if it equals 180, that's a semicircle. Okay. So I got 220, 220, 180, 220. Okay, so I'm starting from Z, W, S. Okay, nice. Yes. Okay, so you're adding 40, 20, 120, and 40. So 40 and 40 is 80 plus 20, that's 100. 100 plus 120 gives you 220. So the major arc of ZWS, you're just adding them up to give me 220. Okay. So if I say KVW, okay, KVW, what is KVW? Starting here with K, ending here with W. KVW. Pre-calculus is not similar to geometry. There are some components. There are some algebra components in geometry, but no. Okay. All right. So I got 220. I got 180. I got 180. Okay. All we're doing is going from K, V, W. Okay. Hello, Henry. All right, so 180, it is 180 degrees because if you take a look at it, it's measuring half my circle. It's a semicircle. It's basically half of it. So that is 180 degrees. Okay, one more. So KVZ. Ooh. Starting here at K, coming here to V, but ending at Z. Okay. So KVZ. What's the angle measure for that? Hey, Pog. Pog says 240. Do we agree? Good. We got one. Junior's agreeing with you. Yep, 240. Okay. CCB is saying yes, 240. Okay. You can take this approach one of two ways. That's the 8th graders now. Awesome. Okay. So we have, you can either add 220, 40, 120, 20, and 40. Okay. If you want to do it that way, you can do it that way. I'm not going to stop you. All right. Or you can say, the whole circle is 360. And I know that 120 is not going to be a part of it. So why don't I take the 360 and subtract the 120 to get the remaining parts of my circle? Okay, so you can approach it one of two ways. All right, so that was 240 degrees. Hey, Minnie. Oh, Clarissa's here. Oh, everyone's coming back. Thank you. All right, so I forgot who asked about tick marks, but here we go. All right, so I want you, Okay, just take a look. Take a look at the circle. And I just want you to find the arc measure. Okay, the arc measure. They're giving us a little bit of hints. They're giving us this box, which means 90 degrees. And they're also giving us hints that these two arcs are exactly the same measure. So they want us to find the measure of AC. So they want us to figure out what's going on. Okay, notice it's two letters. I know a lot of people say, well, Audrey, AC, that means you should be going to your right. No, they didn't mention three letters. They mentioned two. So they're talking about the minor arc. They're talking about this arc right over here. Okay, do we see the difference? Okay, if they mention all three letters, they're talking about the major arc. They're only mentioning two, so they're talking about the minor arc. So, how can we find the measure of this minor arc? Okay. Okay, Ethan, be careful though. Oh, no, actually, I'm thinking wrong. No, Ethan, you're all right. Ignore me. Just ignore me, Ethan. Okay, so we got Angel, we got Ethan. Okay, we got Roy, good. All right, so it looks like if we take our 360, which is the whole circle, take away the 90, and then you get a lovely answer. It's a 270 if I'm not mistaken. And then since there's two equal parts, we're going to divide that by 2. So that means this side is going to be 135 degrees, as well as this side is. So the measure of arc AC is 135 degrees. Okay. All right. Nicely. So, sliding over. This time they want us to find the measure of ACB. So are we dealing with the major arc or a minor arc? ACB, major or minor? What do you think? Okay, good. Major, major, major. Yes. Okay. They're also giving us some indication. They're telling us that all three sections are the exact same. So if we're looking at ACB, so that means I'm going this way. Okay. Go ahead and put your answers in the chat. So I'm seeing some 120s. I'm seeing some 240s. Okay, seeing some 240s, 240s, 240s. Okay, 240s, 240s. Awesome. Because if I divided my entire circle, which is 360, right? Divide that by 3, I'm going to get 120. So, but that's how much each of the sections are. But we are asking for the arc. We're asking for 2 out of the 3. So that means if you add the 120s or take the 120 times 2, you will get your major arc of ACB, and that equals 240 degrees. Okay? All right? You don't know where to begin? Does anyone, Hunter, does anyone really know where to begin? So when it comes down to when they say major, if I go A and I go this way, I got a B. But if I'm supposed to end with a B, obviously I shouldn't go this way. I need to go with the A, with the C, and then with the B. And I know it's going to be a major arc. It's going to definitely be bigger than 180 degrees. All right. So now, this is the other part. So this is the other part that I think I just want to cover this and just stop. Because that was my initial part. The other part that a lot of people get mixed up. There is a difference between arc measure and arc length. Okay? Arc measure deals with the central angle, and you're dealing with the measurement. Whatever your central angle is, that's what the measurement of the arc is. But when I'm talking about arc length, I'm talking about how long is that arc. So if I had, I'll use my little cap right here. If I had my cap and say I had some string, which I don't, but say I had some string that wanted to go from here to here, and I wanted to measure that arc length, just the side of my cap. Okay, I wanted to see how long that is, that arc right there. That's arc length. Okay, so we're taking piece of our circle to figure out what is that arc length. So this is when it gets all kinds of fun. All right. So when we're doing arc length, we are taking the formula. Okay. We're taking the measure of our central angle, which we use the word theta. Okay. Taking that Greek symbol theta, and we're taking it over 360 degrees. The reason why we're taking over the 360, because that's the measure of the whole circle. Now, since we're just looking at the arc length, we're going to multiply that by our circumference. And the formula for circumference usually is 2 pi r. Okay, so we're using this formula to figure out the arc length. So, for instance, let me see if I can zoom in just a little bit. Boop, or a lot. Okay, so when it comes to this 12 millimeter, or 12 meters, sorry, trying to look, notice there was 2 M's. They're talking about the length of my diameter. Notice it's a diameter. It's a chord that's going through the center of the circle from one point to the other point of that circle. So the length of my diameter